Yes, class. From the last class, we had started with EM waves. So what were electromagnetic waves? We have studied that a time-varying electric field, it produces magnetic field, and a time-varying magnetic field, it produces electric field. Now, what will happen? If electric field also exists at a point and magnetic field is also existing. So electric field and magnetic field, since both are present, the wave that will traverse in this plane, we call it as electromagnetic wave because it is having electrical component as well, magnetic component as well. Now, electric field and magnetic field and the direction in which the wave is propagating or moving, you can remember it in simple terms, moving, that is perpendicular. So if your electric field is along y-axis, your magnetic field is along x-axis, so direction of propagation will be along z-axis. All these three should be mutually perpendicular to each other. What is meant by mutually perpendicular to each other? Mutually perpendicular means it's not like electric field and magnetic field are just perpendicular to each other. Magnetic field is also proportional. If electric field and magnetic field are proportional, then it's not necessary the direction of propagation could be parallel with electric field or magnetic. It has to be perpendicular. So all three should be perpendicular. So certain properties also we had discussed in the last class, that electric field, magnetic field, and direction of propagation are mutually perpendicular to each other. Before this, we had seen one more thing. The wave equation, the normal common wave equation that we have. So for electric field, we have E naught sine kx minus omega t. E naught was the peak value. Peak value means the maximum amplitude, you can say the maximum value in the graph that you have. That is the peak value, amplitude. K was angular wave number. This will be used in today's class. These questions are mentioned in your NCRT, back exercises of NCRT, if you see, or in text questions of NCRT, especially in the in-text questions of NCRT, these are mentioned. So if you notice there, you will see K is what? K is angular wave number. Angular wave number is 2 pi divided by lambda, where lambda is your wavelength. Then you have X. X is defines your axis. Plus minus defines the direction of the positive or negative axis. If it's negative, then it's along the positive axis. If it's positive, then it's along the negative axis. Omega, angular frequency, T is time. So that was a complete equation for electric field. Similar equation you have for magnetic field as well. For magnetic field, that becomes what? B is equal to B naught sine kx plus minus omega t. You can even reverse this, omega t minus kx also you can write, because here the significance of negative sign is different. The values and the meaning of negative sign is different. So you can write it on your own. Now the properties, yes. So first property was electric field, magnetic field, and direction of propagation are mutually perpendicular to each other. Now, the electromagnetic wave travels with the speed of light, which is 3 into 10 to the power 8 meter per second. That is the speed of light. In vacuum, you have a formula, C is equal to 1 by mu naught epsilon naught. Mu naught is permeability and epsilon naught is permittivity. So remember, mu naught is from your magnetics. Magnetism, you have derived this. Remember, mu naught by 4 pi is 10 to the power minus 7. So that is mu naught. Epsilon naught is permittivity. And for free space, you have to remember this value, which is 8.85 into 10 to the power minus 12. Got it? Now, if the speed of electromagnetic wave is calculated in some other medium, a different medium, so divide the speed of light by under root mu r multiplied by epsilon r. Both these are what? Epsilon r and mu r. These are the relative permeabilities. So for any medium, you can use this formula. Refractive index and optics, that we'll start optics from the next class, so that time we'll cover. Let us just finish first electromagnetic waves today. Energy density. Energy density is basically energy per unit volume. Whatever is the energy divided by the volume will give you energy density. So it has electrical energies component as well as a magnetic component. Electric fields component will give you electrical energy. Magnetic fields component will give you magnetic energy. So this is energy density. So formula of electrical energy from your electrostatics is half epsilon naught E square, and magnetic energy is half B square divided by mu naught. Fine. So if you combine both of these, this will give you half E square epsilon naught plus half B square divided by mu naught. Now, if nothing is mentioned, by default, this value is your RMS value, root mean square value. So if you have to find out the value for the peak value or the maximum value of electric field as well as magnetic field, what is the value of magnetic field or electric field that you should write? So that will be simply BRMS or ERMS is equal to what? Peak value divided by root 2. By that, when you will square root 2, that will give you 2 only. So this will give you the complete equation as 1 by 4 B naught square divided by mu naught plus 1 by 4 E naught square multiplied by epsilon naught. Now remember one thing, class. Whenever it's electric field, you multiply epsilon naught. That is the permittivity. And whenever it's the magnetic field, you divide it by mu naught. Got it? Divided by mu naught multiplied by epsilon naught. Other things remain the same. Just you have to write the analogous thing. Be careful while writing epsilon naught and mu naught. Where to write mu naught, where to put epsilon naught, when to multiply, when to divide. That is the only thing that is necessary. Then we had seen momentum. Momentum is the ratio of for electromagnetic waves, the energy ratio of the energy to the speed of light. Speed of light is 3 to 10 to the power 8 meter per second. That is fixed. Now, force for an absorbing surface, we had seen F is equal to P by T. This is normally your equation of Newton's laws of equation, second law of equation. Force is what? Rate of change of momentum. So from there, here we have the formula of force as P divided by T. Regarding the second formula, means this is for absorbing surface. Absorbing surface means if this is a surface, light has struck, EM wave, electromagnetic wave has struck the surface. Now, when it is getting reflected back, then the formula becomes slightly different. For that purpose, you have this 2p, because if you put in the sign convention, p minus p will give you 2p. So F will be equal to 2p divided by T. And last was intensity, which is power per unit area per unit time, whose SI unit is watt per meter square. Tell me, class, from here, any doubts till now? We have done revision of the last class that we have done. Clear to all of you?
Yes, ma'am.
All right. Let's do one thing. Let's practice certain numericals now from this topic. Before I start with that, C class. This chapter is mainly divided into 3 parts. One part is this, properties of EM waves. So this major part was completed in the last class, and in today's class, we'll do the numericals that will complete off this topic. And so that was 1/3. Another 1/3 part of this lesson is displacement current. Now, displacement current has recently been added in your syllabus. Last year, displacement current got deleted from the syllabus of class 12th. Now, this year for class 12th, it has been recently added. And not in detail, but slightly you have this detailings about and the minor properties about the displacement current. So, chances of displacement current coming in your exams are much more, because anything that comes in your paper or anything that comes newly and which has not been asked in the past year, the chances of that topic becoming important is much greater. So here displacement current is, so it's very, very small topic that we'll see. It's a very small topic. We'll do it today. And yes, the last part is electromagnetic spectrum. I have shared a table yesterday. Yesterday, I have shared a table. Please check your WhatsApp. I hope you all have received it. So that comprises the production, the properties and frequency, wavelength of the electromagnetic spectrum, the whole set of waves that you have. So you can see, you have to remember that in any case. You have to learn it. You have to remember it. So in anything, in any part, in any kind of wave, you are not able to learn it or are having difficulty in understanding, you can ask me, I'll repeat. But ultimately, electromagnetic spectrums, those points you have to remember on your own. Similar things I have been saying for that table for diamagnetic, paramagnetic, and ferromagnetic substances. And for both of these, I will say this fact that it's better, instead of revising from the table that I've sent you, you make out notes and write the points on your own, but for just to these topics. The rest of the things I write it in the class itself. You just note it down and your notes are already ready. But these two topics, I'll suggest you, it's better if you go through the NCRT and do it. In the NCRT, it's for, especially for electromagnetic spectrum, it's given very neatly and clearly. So you will be able to understand. Many things are there in NCRT that are difficult to understand, but this part is easier. So for both of these, I'll still suggest you that you should revise it from it. Now let's practice some questions. So did you try this question? This is a very easy question, and I think it's a question from your NCRT only, and it has come in your previous years as well. Yes, correct answer, Akif. Exact answer. See, it says what? A plane electromagnetic wave of frequency 25 megahertz travels in free space along x-axis. So direction of propagation. This is along which axis? This is along x-axis. That is, you can say I cap. Electric field is given as 6.3 J cap units. Now, electric field by magnetic field was equal to the speed of light. So here, magnetic field will be equal to what? Electric field divided by the speed of light. Electric field will be 6.3 divided by 3 into 10 to the power 8. This gives 2.1 into 10 to the power minus 8. Now see, electric field is along J cap. Your direction of propagation is along I cap. So can anyone answer what should the unit vector be of the magnetic field?
K cap.
K cap, yes. Because all these three are mutually perpendicular to each other. So if direction of propagation is along x axis, I cap, and electric field is along J cap, obviously magnetic field will be along Z axis, that is K cap. So this is K cap. Note it down, we'll do some more questions. For this question, compare it with the main equation that you have. Yesterday we had written, no, in the last class we had written two equations for electric field and magnetic field. Out of that, for magnetic field, note it down. And then compare and see for what things you require for calculation of wavelength and frequency. Hanifa, see, here you don't have to identify the wave. For identification, that will come from the spectrum part. Wavelength and frequency will be directly mentioned to you. Here, using this equation, you have to calculate what will be the wavelength and frequency. Last 2 minutes class, then we'll discuss it. So answers class. Wavelength and frequency. Right. Right, Krishna, your answer. So only Krishna has answered. See, what's the equation that is given? By is equal to 2 into 10 to the power minus 7. Sine 0.5 into 10 to the power 3x plus 1.5 into 10 to the power 11. Now compare it with the main equation. B is equal to B naught sine kx plus omega t. From this equation, you can easily see wavelength. From this equation, you can easily compare. This is your k. This is also your k. From the, if you compare both these equations, you will understand that this is k given. If you see, this is omega kx plus omega t. Here is also kx plus omega t. Now, if you have k, you can easily get value of wavelength. If you have frequency, if you have angular frequency, you can easily get the value of linear frequency. See for the first part. K is equal to 2 pi divided by lambda. So lambda will be equal to 2 pi divided by k. So 2 pi is 2 into 3.14 divided by k, which is 0.5 into 10 to the power 3. So that becomes 412.6 into 10 to the power minus 3. So 1.2 into 10 to the power minus 2, which can also be written as 1.26 centimeters. That's the wavelength. For frequency, omega is equal to 2 pi by 2 pi nu. So will be equal to omega divided by 2 pi. This will be equal to omega divided by 2 pi. Omega from this equation, you can write it as 1.5 into 10 to the power 11 divided by 2 into 3.14. So that will come out to be 2.3 into 10 to the power 10. This much hertz. 0.38 into 10 to the power 10. Yes, question. First part is correct. Now see, you have the value, you have to find out what's the value of E naught. Because for writing the whole equation, you have to know the equation. You have to know the peak value of E naught. So E naught will be equal to what? Speed of light multiplied by B naught. Speed of light is 3 into 10 to the power 8. B naught is what? 2 into 10 to the power minus 7. So this becomes 16. Now you can write the value of electric field. This becomes E naught sine omega. Now rest of the things you can write it as what was omega? Okay, x 10 to the power k was 0.5 into 10 to the power 3 plus this is x kx plus omega 1.5 into 10 to the power 11 t. This much volt per meter. This complete equation is your electric. Like this, you have to solve all these questions. Note this down. Okay, class, let's take a break of 5 minutes, then we'll start with displacement current. So from this topic, if you have any doubts, you can ask. See, Ampere circuit law we have discussed in chapter number 4. We had done Ampere circuit law. Can anyone repeat what was Ampere circuit law? Fatima? Kulsum, can you answer what was Ampere circuit law?
The formula or the definition?
Yes, the formula and the definition both are the same thing only for it.
Line of integral of magnetic field
Yes.
around a closed path, which is equals to mu times the current enclosed by the path.
Exactly.
Closed interval B dot dl is equals to mu naught I.
Mu naught I. Perfect. So B dot dl, that is the line integral of magnetic field for a closed loop. This is equal to mu naught times, that is the permeability times the current that is enclosed. Now, Maxwell noted that there were certain inconsistencies associated with the Ampere circuit law. This was what? This was Ampere circuit law. This was Ampere circuit law. Now, how he observed were through experiments only. It was through experiments only. So let's say these were the two capacitor plates, spherical capacitor plates were there, battery was there, tapping key was placed, and a whole circuit was constructed. So these are what? These are the capacitor plates. This is the key, this is the battery. Now he did what? He chose two loops. This is the first one, this is C1, this is the first loop, and this is the second loop, C1 and C2. These are the two loops that are present. Now when this whole circuit is connected, when the whole circuit is intact and all the wires are properly connected to the terminals of the battery and are connected to the key and the switch is on, then obviously current will flow through this. Now if you look at this part, C1 part will receive current. So if you write the magnitude of, or if you write the Ampere circuit law, so closed integral of B dot dl for C1, this will be equal to mu naught times the current that is enclosed within the loop, that is I. But if you look at C2, this part, if you look at this part C2, there is no current that is present in this C2. So it means I is 0. If I is 0, then if I is 0, then line integral of magnetic field for the second loop, this is equal to 0. Now, if Ampere's circuit law is B dot dl, which is equal to mu naught I. So for every loop, for every condition, it should be equal to mu naught I. But here, what are we able to observe? Here we are able to observe that values of Ampere circuit law was different. One was mu naught I, the second was 0. So it means there was, this showed the inconsistency in Ampere circuit law. This showed the inconsistency in the Ampere circuit law. This showed the inconsistency in Ampere's circuit law. So Maxwell did what? He modified the Ampere circuit law. There were certain modifications that he made. So first thing that he introduced was the concept of displacement current. There is a conduction current. Conduction current is a normal DC current that is produced in the circuit. So any current apart from the main conduction current, you call it as the displacement current. This is known as what? This is known as the displacement current. So displacement current is what? It is that current that comes into existence in addition to the conduction current. Now, one more thing is there whenever electric field and electric flux change. Whenever the electric field and electric flux change with time. So that additional current apart from the main conduction current, this is known as displacement current. One thing you have to remember in displacement current is its definition, and the second thing that you have to remember is the formula. Displacement current is epsilon naught times the rate of change of magnetic flux, electric flux. This is the formula of displacement current. ID is what? ID is the displacement current. Epsilon naught is permittivity of free space. And dE over dt, this is the rate of change of electric flux. Rate of change of electric flux. So now if you put in the Ampere circuit law, B dot dl for a closed loop line integral of magnetic field, this will be equal to mu naught times the current enclosed. And what's the current enclosed? Now the current is the displacement current plus the conduction current that you had. This now makes your complete I enclosed. So the formula will be what? P dot dl closed integral, this becomes mu naught id plus ic. Just now we have done the formula of displacement current. Displacement current's formula we have done. So line integral of magnetic field, this is what? Mu naught times epsilon naught d phi e over dt plus the conduction current. This is the final formula of the modification that has been made by Maxwell in the law of Ampere. Now you can even prove this. You can even check this. How to check this? Whether now is it consistent? So to check for the consistency, in Ampere's circuital law. Now see, what is B dot dl equal to? Just for the second loop C2. C2, this is equal to mu naught times the displacement current now will come. Initially it was 0. Now it is displacement current. So this becomes mu naught epsilon naught d phi e over dt. Electric flux is what? D phi will be what? Charge divided by epsilon naught. This is your Gauss theorem. So from Gauss theorem, phi will be equal to q by epsilon naught. So put it in this equation. For B dot dl C2, this becomes equal to mu naught epsilon naught q divided by epsilon naught dt. So epsilon naught gets cancelled. Charge divided by time gives you current. Now see what's the formula for the second C2 you are getting. Initially the C2, when there was inconsistency in Ampere's circuital law, this C2 B dot dl for C2 came out to be 0. This is coming mu naught I. And what was B dot dl for C1, where the current had flown? Mu naught I. So it means now you can see both, for both the loops it is coming mu naught I. It means there was a necessity of displacement current to be put along with it. Got it, class? So this is the concept of Ampere's modification of Ampere's circuit law. Note down these points, then we'll see some properties of this and the questions to it. See, there are certain properties of displacement current, mainly 4 important properties that you have to remember. First property, you have to remember that whenever there will be a change in electric flux, then only you will get displacement current. So whenever a change in flux will be there, displacement current will be reduced. Second point is that it's just something additional to the current density. It adds current density to ampere circuit law. It's not actually a current. It produces magnetic field. That's why we call it current. So second point, it produces magnetic field. Third point is that the magnitude of the displacement current, this is equal to what? This is equal to rate of displacement of charge from one plate of the capacitor to the other plate. This is directly proportional to what? The magnitude of charge. So magnitude of displacement current is equal to the rate of displacement to the rate magnitude of ID. This is equal to the rate of displacement of charge from one capacitor plate to another. From one capacitor plate to another. Fine. Last property is that it satisfies the property of continuity. It means there is no breakage in this. So it satisfies the property of continuity. So just note down this, all these 4 properties, and we'll do a numerical. 8.85 amperes. No, Krishna. See, let me discuss it with you. Parallel plate capacitor has circular plates, each of radius 5 centimeters, which is 5 into 10 to the power minus 2 meters. It is being charged so that electric field in the gap between its plate rises steadily at the rate of, means DE, change of electric field or rate of change of electric field is given 10 to the power 12 volt per meter per second. Displacement current is asked. If you remember the formula of displacement current is what? ID is epsilon naught d phi over dt. Now, phi is what? Phi is electric field multiplied by area. So here also it will be electric field multiplied by pi r square. Put it in this formula. This becomes epsilon naught dt. Instead of phi, you will put E into pi r square. Now, E by this is already given to us as 10 to the power 12. So this becomes epsilon naught dE over dt multiplied by pi r square. Now just put in the values in this formula. This is equal to what? 8.85 into 10 to the power minus 12. This is 10 to the power 12. No, just check. 10 to the power 12. 3.14 into 5 into 10 to the power minus 2 whole square. So when you solve this, the magnitude of displacement current that you will obtain will be around 0.07 amperes, around this much. Please check it once. Please check the calculations once. Your answer should come around 0.07 or 0.08 amperes. And text me done when you have written the solution. What about others? Others have also completed. Just text me done when you have written. Then I'll stop. Okay, class, and all of you have written it. Now, see, your first book is over. EM wave chapter number 8 is also over. Please study the electromagnetic spectrum. After Monday, after Tuesday, you can study. So on Tuesday, you will be having your test of alternating current. First, prepare your alternating current first. That's a difficult chapter. That's more difficult than this lesson EM waves. And after that, we'll have a test of EM waves, so you can prepare in that duration. And do study that table and try to make notes from NCRT whenever you get time. And practice alternating current. We'll have a test on Tuesday. So any doubts you have from the first book, any topic, you can let me know. After AC's test and 1 or 2 tests of 1 or 2 lessons, we'll have the revision classes and revision tests will also begin. All right, class. So thank you so much. Any doubts you can ask me, text me on WhatsApp as well. Okay, thank you so much. Goodbye.
Thank you, teacher. Thank you.
Thank you, ma'am.